Sorry about that. My phone, I had a phone call and the video got cut out, so we'll pick up where we left off. So yeah, we just got done assigning the oxidation numbers here. So copper is a 0 because it's by itself, it's a neutral compound. The silver is over here, it's a neutral compound, it's by itself, so it's an oxidation number of 0. We figured out that silver's got a +1, figured out that copper's got a +2. Okay, so then how are these oxidation numbers going to help us figure out what's being oxidized and what's being reduced? What you're going to do is you'll kind of see what happens on each side. So the silver over here is a +1 charge, but then it goes down to a 0. So it went from a +1 to a 0. That means its number went down, right? So that must mean that in order to get that oxidation number go down, it means it gained electrons, because electrons have a negative charge to it, right? So this went from a +1 down to a 0. It actually the number got reduced, is another way of thinking about it. So the silver here is going to be what's being reduced. Now let's look at the copper. The copper is going from a 0 to a +2. Okay, so that suggests, so that number went up. So that suggests that it lost negatives, right? Because it went up. It must have lost electrons in this process. And that's exactly what happened. So if this thing lost electrons, you can see that this one is going to be oxidized. Because if you remember, right, just remember oil rig, right? That if you have a loss in electrons, it's going to be oxidized. If you have a gain in electrons, it's going to be reduced. So the silver went from a +1 down to a 0. That suggests that it gained electrons. Its oxidation number got reduced. This one is going to be the guy that got oxidized because it lost its electrons. Okay. So now we figured out what's being reduced, what's being oxidized. There's another thing we have to do in this problem. It asks us to identify the oxidizing agent and the reducing agent. And if you remember right, I told you guys that once you figured out what's being reduced and oxidized, you just flip that terminology. So this is going to be the oxidizing agent, and this one will be the reducing agent. So it's really as simple as that. We are going to have a lot more practice with assigning these oxidation numbers. Another thing you might have noticed with this problem is we didn't do anything with the nitrates. That's because when we're talking about oxidation and reduction, we're looking at the metals, like what's being oxidized and what's being reduced. So the non-metals, like the nitrates, we're not really concerned about. So we don't necessarily have to assign that oxidation number. All right, so let's try a couple more here. Let's see here. Let's look at, let's just look at letter B. Okay. So it says determine what is oxidized and what is reduced in each reaction. Then let's identify the oxidation agent and the reducing agent in each case. So what I'm going to do is I'm going to assign those oxidation numbers because that's the easiest way to do it. If they're by themselves, the oxidation number is 0. So here we go. Aluminum, 0. O2, okay, it's O2, but it's still by itself. There's no other elements in it. So it's a neutral compound. So that has an oxidation number equal to 0 as well. So now let's jump over here. Well, now we have a compound. And the other rule, if you have a compound, to assign the oxidation numbers, you are going to look at the charge of the compound. So right here, you have 3 times -2, right? So that means that the oxygen is going to have a charge of -2, but then the aluminum is going to have a charge of +3 to balance it up. All right, so we've assigned our oxidation numbers. Now we can figure out what's being oxidized and what's being reduced. So let's try to think about this again. So we have aluminum is going from a 0 to a +3. So it's going from a 0 to a +3. So I'll write down oil rig. If it's going from a 0 to a +3, does that mean that it gained electrons? It gained negatives? or does that mean it lost electrons? Hopefully you guys are thinking about this at home and going, oh yeah, hey, it's going from a 0 to a 3, it's becoming more positive, that means it lost its negatives. So you would be correct if you thought it lost electrons. You're right. So if it lost electrons, that means this thing's being oxidized. So this guy is being oxidized. Okay. Now let's look at the oxygen here. So the oxygen is going from a 0 to a -2. And in terms of electrons, think about what's happening there. It's going from a 0 to a -2. Is that gaining electrons or is that losing electrons? So what do you think? And hopefully you're thinking that if it goes from a 0 to a -2, it actually gained more negatives, right? It got smaller. So that's going to be reduced. And then once you figured out what's oxidized and what's reduced, it's actually pretty simple. For the other part, you just go RA and OA. I will leave letter A up to you guys. I will throw the oxidation numbers on here. You guys go ahead and give it a try. So there's the oxidation number, 0, 0, +1, -2. Try that one. Make sure you guys can do it. Okay, so let's look at a different style problem that we can see in this chapter. It says identify these processes as either oxidation or reduction. Okay, so we know our mnemonic here is oil rig. Okay, oil rig. So we know that oxidation is the loss of electrons, and we know that reduction is the gain in electrons. So these are showing the half reactions that I was telling you guys about earlier. Okay, so the electrons are over here. Is this showing that we gained electrons or lost electrons? Let's think. Let's see here. Well, this almost looks like it's kind of releasing those electrons, like it's losing them. So if you said that this one is losing, you are right. And it would be oxidation. Okay, so let's look at this one here. And when you're looking at that half reaction, electrons are over here on the left side. Looks like the zinc is gaining electrons. So if you're saying that this one is reduction, you are right, because it gained electrons. Okay. So let's just kind of skip over that. Here's a nice table summary showing these different processes leading to oxidation and reduction. The big ones right here, I'll highlight the big ones. The complete loss of electrons, we know that that is oxidation. The complete gain of electrons, we know that's going to be reduction. We know that if a substance being oxidized, that it's gaining oxygen. We know that if a substance being reduced, we know it's losing the oxygen. The other big one that we use a lot in this chapter is this right here. The increase in the oxidation number. So I'll even write that example down here. That'd be, when we assign those oxidation numbers, that'd be like an element A, okay, have an oxidation number of like 0, and then element A on the other side has an oxidation number of 3. As you can see, the oxidation number went from 0 to +3. We had an increase in the oxidation numbers, which you guys should be able to figure out that you're losing those electrons. That's why there's an increase. The other big one is right here, a decrease in the oxidation number. So this would be like if we had element A with an oxidation number of 3, and then element A on the other side has an oxidation number of like 0. So this is how you tell if a substance is being reduced. It just has a decrease in oxidation number. This is how you tell if it's going to be oxidized. Like I say, tomorrow or the next day, we'll have another video up about how to assign the oxidation numbers. It's really not that difficult of a process. So let's switch gears here and let's talk about corrosion. You guys should know a little bit about corrosion, especially because we live in Minnesota and our vehicles rust. So as you guys know, it is an oxidation reduction reaction. The iron oxidizes and it forms rust. Here's the equation. So you need water in order for something to rust. Without the water, it's not going to rust. When you throw salt on the roads and water, it corrodes it even faster. Aluminum, believe it or not, will rust and corrode a little bit, but aluminum's a really cool metal, and it's probably why it's one of my favorite ones, is because aluminum isn't just going to rot away. Aluminum actually forms aluminum oxide kind of at its surface, and then no other oxygen can get down to this pure aluminum down here. So aluminum doesn't oxidize very easily. That's why I have like a 1983 fishing boat that's aluminum, and I don't have any rust holes in it or any corrosion holes in it. But if that boat was steel, I probably would at this point. So what can we do? Because steel is so strong. What can we do to help with corrosion? One of the easiest things to do is paint it. Prime it and paint these rust surfaces, or the metal surfaces, and it'll prevent it from rusting because of that coating, because water needs to get in there to cause it to rust. The other thing that we can do to help with corrosion is galvanizing the steel. There's a lot of, it's called zinc galvanizing. So ships have zinc galvanizing parts. Vehicles have galvanized steel, where they dip it in a hot bath of zinc and then it gives it that protective coating. Vehicles, like the older vehicles, when they first started making cars, they didn't do the galvanizing process on them, so cars back in the day really rusted away really fast. And then automobiles got smart and decided to do this galvanizing process, and the vehicles are lasting a lot longer on the roads. They're not rusting as fast. So same thing with the steel ships here. It's not going to rust as fast. All right, so you guys will have Schoology assignment 20.1. I'll see you next time, more on the oxidation reduction.